when you want to factor quadratics with a coefficient greater than 1. So what that means is, here our leading coefficient, the number right in front of the highest raised term, so in this case it's going to be the n squared, this number before it is greater than 1. Okay, when we want to factor these to get them back into their binomial form, the process is going to look slightly different than if it were to be a coefficient of 1. Okay, and I'm going to walk you through the process of how we would factor both of these. I'm going to show you two different methods. One of them is factoring by grouping. The other one is factoring using the X method. Okay, so when we factor, our first step is to find two numbers. Okay, we have to find two numbers that multiply to a times c. So we have a times c, those two numbers there. But they also have to add to b. Okay, so b is like this middle number here. Okay, it's a lot easier to find two numbers that multiply to a number than two numbers that add. Okay, so we're going to find if a times c here, 6 times negative 6 is going to be negative 36. There's only so many pairs of numbers that can multiply to 36, but a ton of pairs of numbers that can add to 5. So you can go out and you can write out all of these factors, 1, 36, 2, and 18, etc., etc. But I think you'll find 4 and 9, specifically negative 4 and 9, because see this 36 is negative here. One of these terms does have to be negative. And since this 5 here is going to come out as positive when we add the two terms together, that means that the bigger number has to be positive. Okay? So negative 4 and positive 9, when added together, are equal to 5. Which means that if we want to take this and rewrite it so that it's equivalent, but maybe works a little bit better for our purposes, then we are going to expand it here, okay? So we're going to take 6n squared, and since negative 4 plus 9 is equal to 5, we can take this and expand it out to negative 4n plus 9n minus 6, okay? Now, where factoring by grouping specifically comes in, now that we've expanded this, we have two equal groups. So we have two groups of two terms, okay? We have 6n squared minus 4 and 9n minus 6, okay? Once we've found these groups, what we need to do is we need to divide out the greatest common factor. So the greatest common factor is a factor that both of these terms in these parentheses, so 6n squared minus 4n, these two share a factor, and 9n minus 6, those two will share a factor. Okay, so with 6n squared minus 4n, our greatest common factor is going to be 2n. Okay, we can divide both of these terms by 2n to take out that greatest common factor. So 6n squared divided by 2n is going to be 3n, and negative 4n divided by 2 is going to be negative 2. Okay, our greatest common factor for 9n minus 6 is going to be 3. Okay, so we can divide 9n by 3 to get us 3n. And then we can divide negative 6 by 3. I'm going to change these colors so it's a little bit more consistent. Negative 6 divided by 3 is negative 2. You guys will notice that these here, these binomials in these parentheses, are the exact same. Okay, so that means that this is going to be our first, that's supposed to be a 2, not a 3. That means that 3n minus 2 is going to be our first factored binomial, okay? So once we take those down to the answer, all that's left here is what is on the outside of those parentheses. Those two are going to come together to form our second binomial, okay? These are our factored binomials. We have successfully unfoiled this quadratic here, okay? So the second way that we can factor these quadratics is through the x method, okay? Just like with a leading coefficient of 1, we start our x method off by drawing an x, okay? We still have to find those two numbers that multiply to a times c and add to b, okay? So a times c, we have to find two numbers that multiply to a times c, so 3 times 4 is 12, and adds to b. Okay, so our b is -8. And again, there's significantly less pairs of numbers that we can multiply together to get 12 than there is pairs of numbers we can add to get -8. So we're going to start by finding some factors of 12. Okay, so we can do 1 and 12, 2 and 6, 3 and 4. Okay, so this 12 here is positive, but this 8 is negative. Okay, negatives don't just show up out of nowhere. Negatives have to come from somewhere. There are two ways that we can multiply numbers together to get a positive 12. Okay, and that's either that both of these terms, so both of these numbers are going to be positive, or both of those numbers have to be negative. Okay, so if this number that we're adding to is negative, then that means that both of our terms are going to have to be negative in order to satisfy both of these rules. Okay, so you guys can probably see here, -2 plus -6 adds together to get -8. Okay, so those two are going to come over here on the sides. All right, so now because we have a coefficient higher than 1, that means that in order to find these two factors, we had to combine 3 and 4. Okay, that poses a bit of a problem because we've combined together two numbers when each of these individually play their own role when we are foiling two binomials together. That means we have taken 3 out of its place. We need to make sure that we find where it's supposed to be in the end. The way that we do that is if we got both of these terms, this -2 and this -6, by multiplying together 4 and 3, then the best way to put it is that we have to unmultiply it. So the opposite of multiplication is obviously division. So we take both of these terms, both of these numbers, and we divide them by a. So whatever number is in the a's spot, we divide these two factors that we have found. Okay? Next step, we have to simplify because we're trying to find exactly where 3 belongs. Okay? If we can simplify either of these, so -2 divided by 3 or -6 divided by 3, if we can simplify that into a single integer, so in this case, this one simplifies to -2, then we know that's not where 3 belongs. Okay, that's just going to come down here as a regular binomial, just like we did with factoring with coefficients of 1. But this one right here, -2, cannot divide by 3 without turning into a decimal. So that cues us in. This 3 here is important. Okay, this 3 is going to come down here, and it's going to go right in front of that n. This over here is supposed to be an n. I apologize. Okay, this 3 is going to come right in front of the n. So then when we multiply these two binomials together, when we FOIL them back together, we can see 3n times n is going to get us our 3n squared up here. Okay? This -2 here just comes down like it normally would, to be subtracted from that 3n. Okay? That is going to give us our two factored binomials for this quadratic. Okay? In my professional opinion, I do believe that factoring by grouping is going to be the most accurate consistently. Okay? The X method will still work, but when you do the X method, you must check your work. Okay? Because sometimes when you start to simplify these towards the end, you're going to get some weird answers. Sometimes they're going to simplify a little bit more than they should. And when you get these binomials here, if you try and FOIL them back together, they're not going to get back to where they are up here. It's not going to equal this quadratic up here. So you need to check your work, because if the X method doesn't work and you can't pinpoint why because you've done all of the steps, you need to come over and factor by grouping. All right, I want you all to know how to do both, and I want you all to know when you should use them. Okay, both of these methods will work in theory, but the X method can get a little confusing sometimes. So if it doesn't work, go to factoring by grouping, and everything should work out perfectly fine. Okay, I believe in you all. We can do math.